Consider the truth table shown on the screen. How can we take the data in this truth table and write a function using the variables a, b, and c? Enter Carnot maps. The Carnot map will be very helpful for us to write a function that describes this truth table. So we have 3 variables, so we need a 3-variable Carnot map with 8 squares. Now the 8 squares will match the 8 different input possibilities that we have here. So this is just one of the 2 ways in which we can draw a 3-variable Carnot map. So we're going to have 2 rows and 4 columns. So on top, I'm going to put the inputs A, B, on the bottom, C. So now the inputs A, B, it could be 0, 0, 0, 1, 1, 1, and 1, 0. Now the input for C is only 0 or 1. Now the values that we're going to put inside the square are the function values that we see here. So for this first square, A, B is 0 and C is 0, which corresponds to a function value of 0. Now for the next one, A, B is still 0, which means we're dealing with this column, and C is 1, so we're dealing with this particular square. The function value for that is still 0. Now for the third row, we can see that AB is 0, 1, and C is 0, and the function value is 1, so we're going to put a 1 for that square. Now for the next one, AB is still 0, 1, and C is 1. So here's where AB is 0, 1, and C is 1, giving us this square, which the function value is 0. Next, AB is 1, 0, so we're dealing with the last column, and C is 0, so the function value is 1. Now for this one, AB is 1, 0 still, C is 1, and the function value is 1. Next, we have AB is 1, 1, so that's the third column, C is 0, and the function value is 1. And for the last one, the function value is 0, where A, B, and C is 1. So that's how we can take the data in a truth table and put it on a Carnot map, or for short, we could say K-map. Now, how can we take this data and turn it into a function? What we need to do is basically circle groups of 1s together. We can circle 1, 1, or we could circle 2 1s, but we cannot circle 3 1s. The number of 1s that you can circle could be 1, 2, 4, 8, and so forth. It has to be a power of 2. So you can't circle 3 1s, 5 1s, 6 1s. Not going to work. So the best thing we can do is circle 2 groups or 2 pairs of 1s. Let me use a different color so you can see it. So let's start with this one. Now, what information can we derive from that group of 1s? Those 2 1s highlighted, do they depend on the input A? Notice that the input A varies between 0 and 1, yet the output is the same. So the output for those 2 1s doesn't depend on A. Notice that it depends on B. When B is 1, the output is 1. So we're looking for the variable that doesn't change. B doesn't change. So should we write B or not B? Because B is 1 and the output is 1, we're going to write B. Now, these 2 or this pair of 1s also corresponds to a C value of 0. Notice that C is always 0 for that pair of 1s. So because C is 0 and the output is 1, we need to write not C. Now let's move on to the next pair of 1s. So let's put an OR symbol represented by the plus sign. So for the second pair of ones, what variables do not change? So notice that C changes. So for this pair of ones, it is independent of C. But notice that AB is the same. A is 1, B is 0. So which one is going to be not A? Is it A or B? So because A is 1 and it matches the output function 1, we're going to leave it as A. But because B is 0, we need to put not B, because not 0 is 1. So this is the function that explains this truth table. And we could test it out. So let's see if A is 0 and if B is 1 and if C is 1, if we get a function value of 0. So B is 1, C is 1, A is 0, and B is 1. So if we write the complement of 1, that's going to be 0. So we have 0 times 1, which is 0, and 0 times 0 is 0, so we get an output of 0. So that worked. Let's try another one. Let's try this one. Let's see if the function will give us the correct output. So B is 0, C is 1, A is 1, and B is 0. Now the complement of 1 is 0, and the complement of 0 is 1. 0 times 0 is 0, 1 times 1 is 1, 0 plus 1 is 1. So we get the right output. Now for the sake of practice, and to make sure that we have the right function, let's try the last one. So B is 1, C is 1, A is 1, and B is 1 as well. So the complement of 1 is 0. And 1 times 0 is 0. 0 plus 0 is 0. And we can see that we have the correct output. So we have the correct function. So that's how you could use a Carnot map to quickly write a function that corresponds to a truth table. Now let's take the function that we have and turn it into a circuit diagram. So the function that we have was B times the complement of C plus A times the complement of B. So we can write that as B C prime plus A B prime. So we need an AND gate to connect B and C prime. So let's start with that. And we need another AND gate to connect A and B prime. So this is going to be B and C prime, and here we have A and B prime. Now notice that we have a plus symbol between these two terms. So we need to use an OR gate. The plus symbol is associated with the OR operation. So the output of this AND gate is going to be B C prime, and the output of this AND gate is going to be A B prime, and the output of the OR gate is going to give us the function f, which is what we have here. So that's the circuit diagram that corresponds to this function. Now let's try another example. Let's use this truth table to create a K-map and then use that to write a function, which will then use that to turn it into a circuit diagram. If you want to pause the video and try this problem, feel free. Now, the type of K-map that I'm going to draw is going to be a little bit different than the last one. The last one was a 3-variable K-map drawn in the horizontal direction. But I'm going to draw one with a vertical orientation. So instead of having 2 rows, 4 columns, I'm going to have 2 columns and 4 rows. So I'm going to put one variable above the diagonal line, two variables below it. So A has two possibilities, 0 or 1. BC can be 0, 0, 0, 1, 1, 1, or 1, 0. So that's how you can draw a three-variable K-map with vertical orientation. Now, let's fill in a table. So for this first column, A is 0, which we can see it for the first four inputs. So here, when B and C is 0, the function is going to be 0. And when BC is 0, 1, the function is going to be 1. When BC is 1, 0, the function is 0. And when BC is 1, the function is 1. Now for the second column, A is always 1, which will correspond to these four. So when BC is 0, the function is 1. And when BC is 0, 1, the function is also 1. When BC is 1, 0, the function is 1. And when BC is 1, 1, the function is 0. So that's how we can quickly fill out this K-map. Now, how can we use it to write a function for the truth table? So let's start with this pair of ones. Notice that A is always 0. So we need to write the complement of A, because the complement of 0 will give us an output of 1. Now for those pair of ones, notice that B changes. So the output is independent of B, so we're not going to include B. But notice that C is 1, so we're just going to write C. Now let's draw the next pair of ones. So notice that A is always 1 for that group. And this time, C changes, so it's independent of C, but B is consistent. B is always 0. So we're going to write B prime. Now there's only one last one that we need to consider, and that's here. So A is 1, we're just going to write A. B is 1, we're going to write B. And because C is 0, we're going to write C prime. So this is the function that corresponds to this truth table. Now let's test the function to make sure that we do indeed have the right one. So let's start with what we have here. So A is 0, C is 0, A is still 0, B prime, B is 1, and then we have A, B, C prime. So A is 0, B is 1, C is 0. The complement of 0 is 1. The complement of 1 is 0, and the complement of 0 is 1. 1 times 0 is 0, 0 times 0 is 0, and 0 times 1 is also 0. So this adds up to 0, which we can see that's the case. Now let's try one more. Let's try this one, where A, B, and C is a 1. So we have the complement of 1 times 1 plus 1 times the complement of 1 plus 1 times 1 times the complement of 1. The complement of 1 is 0. So automatically 0 times 1 is 0, 1 times 0 is still 0, and the last one is going to be 0. So the output is once again 0. Okay, let's try one that's going to give us a value of 1. Let's try this one. So A is 1, C is 1, B is 0, and A is 1, B is 0, C is 1. So the complement of 1 is 0, the complement of 0 is 1, and the complement of 1 is 0. 0 times 1 is 0, 1 times 1 is 1, 1 times 0 times 0 is 0. 0 plus 1 plus 0 is 1. So this function works. So now you know how to write a function using the K-map. But now let's turn this function into a circuit diagram. Let's draw the logic circuit that corresponds to this function. So let's start with the first term that we have. So we need an AND gate. So it's going to be A prime C, and the output will be A prime C. Now for the second AND gate, the input will be A, and the second input is going to be B prime, giving us the output A, B prime. Now for the last one, I'm going to use a 3-input AND gate. So the 3 inputs will be A, B, and C prime. Now we need a 3-input OR gate. So then this will give us the output function f. And so that's how you can draw the logic circuit for this particular function. Consider the 4-variable K-map that we have on the screen. Go ahead and write a function for this K-map. Feel free to pause the video. So first, let's begin by analyzing those two pair of ones. So notice that A and B is always 1 for that selection. So we have A and B. And for that selection, notice that C is always 0, but D changes. So it depends on C, but not D. So we have A, B, and since C is 0, we're going to have C prime. Now let's select another pair of 1s. So let's go with that. Now notice that A is always 0. So we're going to have A prime. B changes, so it's going to be independent of B. Now C is always 1, and D is always 0, so we're going to write D prime. Now let's select this pair of 1s that we have there. So A is always 1, and B is always 0, so let's write B prime for that part. Now, notice that C changes with the numbers 0 and 1, but D remains the same. D is always 1. So this is going to be A, B prime, D. So this is the function that corresponds to this particular 4-variable K-map. Let's try another example. Go ahead and try this one. So instead of selecting 2 1s, we can select a group of 4 1s. So for that particular group, which variables remain the same? Notice that A is always 0 and B is always 0. So we're going to have A prime and B prime. Now C can be 0 or 1, so it's independent of C, and D can also be 0 or 1. So it's only going to depend on A and B for that first selection. Now the next selection, we can basically take a square of 1s. So which variables are constant? Notice that A is always 1, so we're going to write A. B changes between 1 and 0, so it's independent of B. On this side, notice that D is always 1, so it's going to depend on D. C changes, so it's independent of C. So this particular function is represented by this equation. It's A prime B prime plus AD. So now you know how to take the information from a 4-variable K-map and turn it into a function. Now let's say that we're given a function AC plus AB prime. So how can we take this function and create a 3-variable K-map? And let's create it in the horizontal direction. So we're going to need 2 rows and 4 columns. So we're going to put AB above the diagonal line and C below it. So AB can be 0, 0, 0, 1, 1, 1, or 1, 0. And C could be 0 or 1. Now let's focus on the AC term. Notice that we don't have any complements here. So we're looking for when A is 1 and when C is 1. C is 1 anywhere in this row. A is 1 here. So what we're going to do is we're going to put a 1 in those boxes. Now let's focus on the next term, AB prime. So we just have A, we're going to put 1. We have the complement of B, so we're going to write 0. So let's identify where A is 1 and B is 0. So this is when A is 1 and B is 0. So anywhere in this region. So we need to fill this row with a 1, and we have an overlapping 1 there. Now every other box, we're going to put a 0 in it. So that's how we can take a function and draw a K-map from it. Now let's try another example. So let's say the function is a b prime plus ac plus a prime bc prime. So let's create another 3-variable K-map, but in the vertical orientation. So we're going to have 2 columns and 4 rows. So we're going to put the letter A on top, BC below the diagonal line. So A can be 0 or 1, BC can be 0, 0, 0, 1, 1, 1, or 1, 0. Now let's start with this term, AB prime. So A is going to be 1, B is going to be 0. A is 1 in this column. So let me just highlight that in red. And B is 0 here. So that means we're going to put a 1 in those first 2 boxes on the right. Now let's move on to the next term, AC. So that's when A is 1 and when C is 1. So we need to put a 1 here and here. Now for the next one, we have A prime, B, C prime. I forgot to put 1, 1 for that. Now for A prime, we're going to write 0. For B, we're going to put 1. For C prime, we're going to write 0. So A is 0 in the first column, and B is 1 here, and C is 0 here. So we want A to be 0, and B to be 1, and C to be 0. So that only corresponds to this last square. So we're going to put a 1 there. So every other box, we're going to put a 0. And so that is the K-map that corresponds to that function. Here's another harder example. Let's say the function is AB prime plus A prime CD plus A B C prime. Go ahead and draw a K-map for that function. Now what type of K-map do we need? Would you say it's a 3-variable K-map or a 4-variable K-map? Notice that we have 4 variables, A, B, C, and D. So this time, we're going to need 4 columns and 4 rows. So let's put the letters AB on top and CD on the bottom. So AB could be 0, 0, 0, 1, 1, 1, and 1, 0. And the same is true for CD. Now, let's focus on AB prime. So we have A, which we're going to put a 1 for that, and for the complement of B, let's put a 0. So when is A 1 and when is B 0? A is 1 and B is 0 anywhere in this column. So we're going to put a 1 everywhere in that column. Now let's move on to the next term, A prime CD. So let's put the 0 for the complement of A and a 1 for C and D. So notice that C and D is 1 in this region, and A is 0 in the first two columns. So therefore, we have to put a 1 at the intersecting squares. Now for the last term, A, B, C prime, we're going to put a 1 for A and B and a 0 for the complement of C. So A and B are 1 in this region. C is 0 in the first two rows. So we're going to put a 1 here. Everywhere else, we're going to fill it in with a 0. And so now we've completed the 4-variable K-map. Let's work on one more example. So this one I'm going to color code differently. So let's say the function is C AD prime plus A prime B C prime D plus A B prime C. So go ahead and fill out the 4-variable K-map given this function. So let's start with the letter C. So since we have C and not the complement of C, it's just going to be 1. C is 1 in this region. So that's anywhere in the last two rows. So we're going to have to put a 1 in all of those rows. In those two rows. So I'm going to color code this group of 8 ones. Notice that when we have just a term with 1 variable, we're going to get 8 ones. For a term with 2 variables, we're going to get 4 ones. For a term with 3 variables, we're going to get 2 ones. And for a term with 4 variables, we're only going to get 1 1. So let's move on to the next one, AD prime. So for A, I'm going to put 1, and for D prime, 0. So A is 1 in the last two columns on the right, and D is 0 here. So we're going to have a 1 and D's as well. So now I'm going to circle those ones with a red color. So as we can see, for a term with 2 variables, we have a total of 4 ones highlighted in red. Now let's move on to the next term, which has 4 variables. So we should only get 1 1 in the K-map. So for A prime, we're going to write 0. For B, 1. C prime, 0. D, 1. So when A is 0 and B is 1 here. C is 0 and D is 1 here. So we're just going to put a 1 in this region. And I'm going to highlight it in green. Now for the last one, A, B prime, C. So we're going to have a 1 for A, 0 for B prime, and a 1 for C. So first, let's identify where AB is 1, 0. So that's going to be in this region. And now let's identify where C is 1. C is 1 in the second and the third row from the top. So we're going to need a 1 here and the 1 that we already have here. So as you can see, for a term with 3 variables, we get a pair of 1s or 2 1s. Everything else, let's put a 0. And so now you know how to turn a function into a K-map. So that's it for this video. Thanks for watching.